Hello, everyone. We are excited to present our project titled Job Resume Analysis and Recommender System as part of our DSC 478 coursework on programming machine learning applications. Next, uh, let's begin by understanding the motivation behind our project. So today, platforms like LinkedIn and Indeed connect over 250 million active job seekers with potential employers. However, the initial screening of resumes remains largely manual. So studies show recruiters spend just 6 seconds on average skimming a single resume, making the process not only time consuming, but also inconsistent and prone to bias. To address this, we aim to develop a smart and objective approach for matching resume to job roles. So we incorporated natural language processing, custom feature engineering, and machine learning to recommend relevant jobs for each candidate more efficiently and fairly. Our work is grounded in a real-world dataset from Kaggle, containing 344 unique resumes and 28 job descriptions, creating a total of 9,544 possible resume job combinations. Let's move on to dataset overview. So the dataset is quite rich and diverse. The resumes include details such as skills, education, total experience, certifications, and career highlights. On the other hand, the job postings outline requirements like minimum experience, desired qualification, and key skills expected for each role. So this structured format allowed us to extract relevant patterns. Now I'll forward it to Akansha Singh.
Hi, so we have done exploratory data analysis. We firstly check on the missing values. So we dropped rows with missing values and left with 344 unique resumes and 28 job postings. We have also done some NLP statistical analysis like n-gram frequency analysis to identify unigrams and bigrams like data science, machine learning. Also, we did word cloud visualization to check on most frequently occurring words in resume and job content. Next slide, please. So pre-processing, we have done a low casing where we did it for removing the duplicates to ensure all the words are in the same casing. We also removed the stop words like and, the, is, and punctuations and special character removals also done to for token matching and vectorization. We also removed the duplicates, synonyms and acronym handling. So where we have done all the we have done contextual gaps in the TF-IDF by merging equivalent terms, and we have also done we have assigned the like artificial intelligence like AI, DBMS to database management system. Also done the HTML tag striping where we removed unwanted HTML element present in some resume fields. Lemmatization and stemming reduce words to root forms like running to run, technologies to technology to unify expressions. Feature engineering, we have created and extracted some columns such as unique text job, unique text resume column. We also extracted the total experience year from the resume, uh, like end date and the start date of the candidate. Required experience from the job description, skill match ratio, overlapping words, highest education level, degree type and match, experience flag. To this is done to enhance our content-based scoring and regression model. So now I'll be passed this slide to Krishna.
Hi. As part of our analysis and the modeling methods, we have done PCA to identify the different types of resumes in the data. So we had like only 344 resumes, but we wanted to know like what are the unique varieties of the uh, resumes we have, and we have identified like there are mainly three different categories of jobs this resumes belongs to, or mainly belonging to finance, data science, and the software management in the company. So this clustering analysis is also used as a an additional feature uh, which helps in the regression of the model. So next, we have applied a few vectorization techniques. Like we have done TF-IDF, which was taught in the class, and along with that, we have also experimented with BERT embeddings to check how it is comparing with TF-IDF. So in our recommendation approaches, we have done content-based recommendation and the collaborative filtering. And now we have the option to do the collaborative filtering because we had a matrix of 344 resumes plus 28 job descriptions, and we also had the matching scores for these combinations. So in content base, we have used the TF-IDF vectors to identify the similarity scores, and we have used it to find the top 10 jobs for a given resume. And for our regression model, we have fine-tuned 5 different models. So we have tuned for multiple parameters for these models. The models include linear regression, ridge regression, KNN, gradient boosting, random forest, and XGBoost. So we have identified XGBoost was giving the best results with R square around 0.68 and mean absolute error around 0.07. So from the models, we have identified the ensemble models for outperforming the other models like linear regression and KNN. So these are the overview of the results. So we actually had many checkpoints in our data set. We have experimented uh, without any pre-processing, and we have experimented after handling the null values and after doing the limitation, and also after including the extracted features as well as the text features in the data. And we have found that just using the limitation, the model was performing the best. So I think Ketan can take over from here.
So collaborative filtering was a basic content-based recommendation technique that was taught in class. So we were able to do collaborative filtering by reprocessing the data and then converting it to a utility matrix of 344 rows and 28 columns. And the data was sufficiently dense enough for us to do SVD. However, there were not many missing values, so mm, we did not spend much time on predicting missing values. So technique used. So at firstly we used the user item based matching. So resumes for the user and job for the items. And in contents, we also did content based recommendations. So we calculated cosine similarities between resume job pairs. Now these pairs contained strings, combination of strings for different features like skills, experience, education, universities, etc. We tried a lot of different um, combinations of features to obtain this content-based similarity score. And then for each resume, we suggested top N matching jobs. And we did this at the several stages of the data. So originally, we were getting 34.5% matching, meaning that out of our 5 predictions, 34% of those predictions were actually matching our target feature, which was the match score. And we get better results in top 10, about 50%. So this project was not easy. There were a lot of challenges. The first and the most important challenge was that the resume data was so messy. So it had a lot of HTML text, it has a lot of punctuation marks, and a lot of inconsistencies overall. So another main issue was synonyms and abbreviations. Like a lot of different resumes mentioned machine learning, whereas others mentioned just ML or ML/AI and etc. So the first thing we had to do was to fix that. And another, we tried n-grams and word cloud analysis to find which pairs of words they are most frequent and are very important in a resume. So another limit was that TF-IDF, which was our primary vectorizer, it cannot understand semantics. So that was a big issue which we attempted to fix using BERT before because BERT can understand some semantics. However, as our data was very low in size and we used complex models such as ensemble models like extreme gradient boosting, so there was some issue of overfitting which we tried to fix using parameter tuning. So in our project, we have tried to balance content-based and collaborative filtering. Collaborative filtering was limited because there were not many missing values and we were not able to predict a new user based on other users. Therefore, we moved ahead with a hybrid approach, which required careful design of weights. We tried to give weights in content-based collaborating, as we saw in top 5 and top 10 cosine similarity predictions. So thank you for your time. That was our project on resume analysis and recommender system.